Okay, so just basics about quadratics and looking at graphs and why we do what we do. Why do we do this thing of factorizing? What I've done here, I'm not going to show you how to factorize this in this video, but we have factorized that equation, just the right hand side of the equation. I'll put it equal to y. And if y was equal to x squared, so x times x minus 3 lots of x minus 10, I get a strange graph that looks like this. It's a curve. If I compare that with my straight line graphs from before, well, of course it's a straight line. But the reason why it's a curve is because of this power here. Straight line graphs, you got x just on its own, just not x to the power of 1, basically, not multiplied by itself or anything like that. And just to make sure that we understand what happens when we factorize it, it's equivalent. The equation is the same. So when I turn that one on, it's exactly the same shape. You can see how it just appears over the top of it. Okay, so these equations are identical. All right, but the weird thing is that you'll notice that with the straight line graph, that when x was 0, well, it would be y was equal to 3 times 0 plus 5, which is why we have a y-intercept here. If with this one, when x is 0, well, we have y is equal to minus 10, because 0 times 0 minus 3 lots of 0 would be minus 10. So that's the y-intercept right here. But why do we do it in this way? If we have a look at that one, which is the same as the red one anyway, we've got plus 2 and then minus 5. And if you have a look here, the x-intercepts are 5 and minus 2. So they seem to be the negatives of these numbers in here, 5 and minus 2. So the reason for that, so I know that we have two x-intercepts there, and the reason for that is because if we knew, let's say we knew that, so I'm taking, in this case, on the x-intercept, that's when y is equal to 0 along this x-intercept. Imagine that a times b is equal to 0. What does that mean? It means either a equals 0 or b equals 0. We don't know which one it is, but we can say for sure that one of them equals 0. In the same way up here, when I say x plus 2 multiplied by x minus 5 equals 0, then I'm saying either x plus 2 equals 0 or x minus 5 equals 0. So that would mean that if x plus 2 equals 0, I could rearrange that and say x is equal to negative 2, and rearrange the bottom one and say x is equal to 5. And that is exactly what this graph shows. So when y equals 0, x is 5 and y is negative 2. So that is why we do these factorizing, to find the x-intercept. You can rearrange them another way. You can do something called completing the square, and that helps us to find the bottom value, and it also helps us to find the x-intercept as well, actually. Leaving it in its original, the most generic format, helps you to find the y-intercept, and then by factorizing it helps you to find the x-intercept. And there are two x-intercepts because we can say that either that is the case or that is the case, and it produces this curve like that. Okay.